I'm Megha Ramesh and I'll be explaining the second assignment of design and analysis of reconfigurable systems. In this assignment, we will be prototyping an FPGA board, that is the Terasic DE1 SoC board, and we will output a 4 MSB of a 32-bit counter to 4 LEDs of the DE1 SoC prototyping board. By changing a switch of the board, it should count up and down. The tool requirements are Quartus Prime Light, Questa, and DE1 SoC board. So to implement this, we've already installed Quartus Prime Lite and Questa. This time we have to use the DE1 SoC board for this. The first step is to open the Quartus Prime Lite edition, open a new project, select the Cyclone V5C SEMA board, and then go to File, New, open a new Verilog file, and type in the Verilog code for an LED counter, which shows output in 4 MSB bits of our FPGA. So this is the code for our LED counter. We also type in a test bench for both of them, compile the design. This design is already compiled. And then after that, we will check the output on a simulation tool on Questa to see if this works. If this works, we can implement this in our FPGA. So Questa is opened and we click on compile. File, and we go to the folder which has all the files. We have to add the regular code and the test bench. Then double click simulate. And then go to UUT, right click and add wave. For the ease of reading of our waveform, we change the radix of our output to decimal and we run the code. And we zoom in on the code. We can see that here the counter is counting from 0 to 10, that is up counter. Then when it is switched here exactly, it starts counting downwards. And then again after the switch is passed here, it starts counting upwards. So because of this, we know that our output is correct and this is our desired output. After this, we have to go back to Quartus Prime, go to File, New, and this time add a synopsis design constraint file. So on clicking on this, the synopsis design, a new file will open. Add the synopsis design constraint file to this. And then we'll have to compile the design again to make sure that there are no errors. It's getting compiled now. While the compilation is being done for STC file, we can connect our FPGA board to the laptop. So first we connect the power cord to the main socket, power socket, and then we connect the USB blaster to our laptop here. So the compilation of the STC file is done. Then we connected the FPGA board to our laptop, the system. And then we click on assignments, then on pin planner. So this is the pin planner for our device, the Cyclone V5S SEMA 5 F31C6. So this is something that we selected while we were creating our new project. So based on these, the pins are being assigned, and based on the inputs and the outputs that we've given in the Verilog code, It's been given here as which one of them are inputs, which one of them are outputs. Based on the pins, according to our device, we'll have to assign each of them here with each of the pins that is needed. So the pins can be seen on the data sheet that is being provided by the university, and we can also find it online. So count 0 to count 3 are connected to these pins. These pins are the LED pins. Then direction is connected to the switch, and reset is connected to the reset button. So after these connections are made, the pin locations are assigned. We close this window and go to analysis and synthesis. We have to make sure the IO assignment analysis is being done. So we'll have to save the pin assignment for all the inputs and outputs. So we wait for the compilation of the IO assignment analysis. So after this is done, you scroll down here, click on Program Device, Open Program. Here you click on Hardware Setup, and here we go click on DSoC USB1. Since this is already connected, this is being shown here. If it's not connected, it just remains at no hardware. Then we close it, it's reflected here. Then we do auto detect. After auto detect, we can choose our device here, and since we just compiled it recently, we need to choose the recent SOF file. We change file here and choose the most recent one according to our time. The most recent SOF file, open. So that's been stored here, and then we click on auto detect, and then we click on start. So the entire program has been programmed to our FPGA. It's successful, 100% successful. After it is successful in the programmer here, we'll have to check the output in our FPGA. So in the FPGA, click on reset. So here 4 LEDs are seen. So 4 LEDs represent 15. Now it's counting down 14, 1110, and then it's 1101, 1100, 1011. So it's counting down. So when we press on reset, it starts from 15 again, and then it starts counting downwards. When we click on our switch, it switches from down counter to up counter. So 1011 became 1100, 1101, 1110, and finally it is 1111. We can press reset here as well to see it count from 0 to 15. So it starts from 0, then it is 1, then comes 2, 3, then it's 01004. So it starts counting upwards, and we can switch accordingly. After we see the outputs on the FPGA, now we have to flash this program into the FPGA so that it runs without the connection to the laptop. So to do that, click on File. Next, click on Convert Programming Files. In here, click on JTAG and tag configuration. Then here we'll have to choose our device Cyclone 5, then EPCS 128. Okay. mode is active serial. Then output file, we can keep it as LED counter 2 output file. Then we click on SOF data, and then we do add file. Then we click on the SOF file that's been created already in the folder that there. Sorry, it's here. This one, LED counter 2.sof, and open. And then we click on flash loader, add device. Then we click on our device 5C CMA 5. We click on OK. Then click OK. Then we click on generate. Yes. So a new output file has been generated successfully.
Before flashing into the device, we first flip it over and then we go to the M select here. So we'll have to keep M select in this order where 0 to 4 is considered here as seen here. It's 0 and 1 here. This 0 is 0, 1 is 1, 2 is 0, 3 is 0, and 4 is 1. So we set it like this before flashing it completely into this device.
After the M select pins have been set, we go back to the quarter scrambled edition. Then we go to tools, click on programmer, and we do auto detect here. So now both of them is detected. Then we click on this and we go install the new .jse file that we converted, and this is the new JSE file that's been added. Then we click on this configure box, then we click on start. So as you can see, it is getting flashed here. So it will take time until it reaches 100%.
After the progress is 100% successful, we'll have to check it on the FPGA board. Power off and power on. Then we plug this out and we can see that it is an up counter here. The switch is up. So even without plugging inside, it starts counting upwards. And when you press reset, it goes back to 0 and starts from 1 again. So we reset and change it to down counter. It starts from 15, then 14, 13, and when we press reset, it goes back to 15. Now it's fully flashed.
After the flashing is done, we compile it once again so that we can check the critical path and the delay of our circuit. So it's getting compiled right now. Since all the files .sof, .gic, and .cdf have been updated, it is better to compile it once again so that we get the latest and the most used path, that is the critical path, most time delay path. Since all of it is done now, we go to Tools, Timing Analyzer, then we go to Report Path. Here, since everything is already selected, we just click on Report Path and we get it from node dir to pre-count 28 and the delay is 6.366 nanoseconds. And we save a screenshot of this. And this is the first part of our assignment 2.